Hello friends, in these sessions we are going to discuss about total internal reflection. So what is total internal reflection? This is a common word which we listen in a formation of a rainbow. But isn't it the rainbow formation total internal reflection is that set? Let's visualize. So what is total internal reflection? Total internal reflection is nothing but the reflection of light within a medium. That is the total internal reflection. It is telling that the complete reflection of light ray within a medium such as water or glass from the surrounding surface back into the medium, that is called as total internal reflection. But when this phenomena occurs when the angle of incident is greater than certain limiting angles, and that limiting angle is called as critical angles. Certain limiting angles means it has some specific value. If we exceeds that value while incidenting the light ray, we will see the total internal reflection. So what is a critical angle? Critical angle is also an angle of incident, but in this case when it refract into a mediums, then it refract with an angle that is called as a right angle, that is a 90-degree angles, and that incident angle is called as a critical angle. So we can derive it as when the angle of refraction for any certain angle of incident is 90-degree, that is right angles, then that angle of incidence is called as the critical angles. So next you can see these pictures. These pictures shows the formation of rainbow, and the formation of rainbows forms by three main processes. First, that is dispersion. Second, that is total internal reflection, which we are discussing here, and third, that is refraction. So we are mainly focusing on the second picture, the second pictures which we are going to discuss in this slide only. And the second process of the rainbow formation, that is total internal reflections. So the second picture shows that light was traveling from a denser medium, that is water, to a medium, that is air. So N1 is represented water and N2 is represent the air. We have to keep in mind that total internal reflection occurs if the angle of incident exceeds the critical angle, first point, and the second point which we need to remember is when the light ray is traveling from a denser medium to a rarer medium, right? So let us visualize these pictures. A point was pointed at this point which I had given now is the pointer in the water. So let us assume this is a swimming pool. So from that swimming pool somebody is incidenting a light ray out to the medium, that is water, into the surrounding, that is the airs. In the first case what happens, case 1, that the light ray was traveling from a denser medium to a rarer medium without any refraction. So here the angle of incident is equal to the angle of refraction, that is a 90-degree, because it is traveling along with the normal axis, along with the imaginary normal axis, right? So if I calculate the sin I upon sin r, which is equal to 1, when the sin I upon sin r is equal to 1, then the internal reflection, neither the internal reflection nor any refraction, nothing will happen. It will just simply move from one medium to another medium as the light travel in a single medium. So what I had done is I had bent my incident ray. I had tilted my incident ray a little bit and make a certain angle, that is theta 1, which I had represented at here. I am showing in the pointer, that is theta 1. So theta 1 is what? Theta 1 is here the angle of incident. When the angle of incident is theta 1, then it is refracting. To the air medium, that is theta 2 with the angle of refraction. So the angle of refraction here is, that is theta 2. Here the normal refraction is occurring. So what is refraction? When the incident ray traveling from one medium, whether it is a rarer or denser, to a medium which is just opposite to the optically medium, right, which is just opposite to the optically medium of the first, then the refraction occurs. Either it moves away from the normal or it moves towards the normal depending upon the optical density. So here N1, that is water, is high optically denser mediums, and that is air here is low optically denser medium than the water, right? That is why here the refraction occur, normal refraction occur. Okay, now we heard cross two cases, case 1 and case 2. Let us visualize the case 3, right? So when in the case 3 what was happening, the light ray was traveling, but it was bent a little bit than the case 1 and case 2. So if I make the angle of incident with the normal, then I will see that than the case 1 and case 2, the angle of incident in the case 3 is little bit more, and the refracted ray was not moving out to the medium, that is the air, but where was the refracted ray going? The refracted ray was moving along an imaginary axis which was dividing the medium 1 and medium 2 from each other, that is water and air from each other. If it is moving along that imaginary axis, what is the angle of refraction then? Of course, you can see the angle of refraction is nothing but a right angle, that is 90 degree. It is making a perpendicular angle with the normals. If the angle of refraction is 90 degree for a angle of incident, and that specific angle is called as critical angle. That specific angle is called as critical angle, which is here represented by the letter theta c. Okay, now what I had done is, till now I had increased the amount of angle of incident. In the case 4th, what happens? I had increased the angle of incident a little more than the angle of critical, that is critical angle. If I had increased the angle of incident than the critical angle and case 2 and case 1, what I had seen is the refracted ray which was refracting in the case 1, case 2 and case 3, no refraction is showing. Simply the light ray was traveling within the medium and it just reflects back into the medium. But why that happens? Because as you can see in this picture what I had shown in the pointer, that in the case 3 it was traveling along with this axis. Now if I increase that amount of angle of incident than this point, that is theta c, then what I had shown, that this ray which was traveling along this dividing axis, this ray was just bent into the medium, and that show a reflection, that show what, that show a reflection instead of refraction. If it is showing a reflection instead of refraction, then that reflection is called as total internal reflection. That is nothing but the total internal reflection. So let us quickly summarize the thing which we had discussed here. Nothing but I had done an activity which tells us that when a light ray was traveling from denser medium to a rarer medium without any refraction, case 1, then case 2 it just refracted with an angle, that is theta 2, for some incident ray, that is theta 1, and in the case 3 that a new thing happens, that it moves along with the divider line which was dividing the medium 1 and medium 2 and making an angle of right angle that with the normal, and that specific incident angle is called as a critical angle. And in the case 4, what happens when I increase the amount of incident angle than the critical angle, instead of refraction, the reflection happens, and that reflection is called as the total internal reflection. I hope you had understood this much clearly. So next we are going to discuss what are the application of total internal reflection. Let's see. The first application, that is the shining of diamond. The diamond shines because of total internal reflection. And as you know that diamond is a thing which has a very high refractive index. And that high refractive index is also a region behind the brilliance of diamond as well as the total internal reflection. First application is done. And the second application that we use in our day-to-day life, that is optical fiber. So now what is optical fiber? Optical fiber is an imaginary wire. If I visualize that optical fiber, it will look like this. This is the figure of an optical fiber which brings the internet connections to our homes. That is the optical fiber. It is used in instruments like telescope, microscope, binocular, spectroscope and periscopes, etc. These are the devices where the optical fiber used. And this is the picture of optical fiber. But what happens inside this optical fiber, so that we are telling that this is an application of total internal reflection? It will look like this. This is simply a piece of optical fiber which I had taken, and when I incidented a light ray into these optical fibers, then what I see? I see that the light ray was traveling with a zigzag motion, as you can see in this picture, zigzag motion. So light ray was traveling without refraction. It was just traveling with reflection. It was traveling within a medium that is a solid, that is a optical fiber. So what happens here is the critical angle is not at here. That the angle of incident at each point of reflection exceeds the critical angle. The angle of reflection, the angle of incident at each point of reflection, right? The angle of incident at each point of reflection is greater than the angle of critical. That is, angle I is greater than angle C. If this happens, then the total internal reflection happens. What is happening at here? You can do it by your homes. I will show you how to do. Let's see. What you need to do, one thing is, take simply a beaker or any plastic cover, that is plastic jars. Fill half of it with water. Then what we need to do is just bring a laser light and incident it outside the surface of this pot. When you incident that, sometimes what happens, first case, you will see that the light ray was just a single ray and it was vanished after that. Where that light ray go? Then what we'll do, then we just tilt a little bit that incident ray. Then you will amazed to see that all the light ray will move like this till the water is filled, till the jar has ended. From, if this side is the incident side, then till this side is the refracted, means the opposite side of the incident, then you will see the total internal reflection till this much. So that's all for today. I hope you had something learned from this video. So thank you. Goodbye.